Alright guys, here we go. This is us moving on to week 6. We're still in this idea of statistics. This is kind of giving you a basic idea of a bunch of different types of statistics for this week. Um, Last week we went over standard deviation. This week we're going to see how standard deviation can tell us some more information, specifically on this idea here of the normal curve. Now, the normal curve, we're going to use it to be able to look at some different populations, find some percentages, and some specific pieces of data. Today, all we're going to do is kind of go in and introduce you to the normal curve, some information that we can find using it, and then as we go throughout this week, we'll find some specific information from this normal curve. The first thing I want to do, though, is a little bit of review here. Again, the mean over here, we're looking at the mean is we're just gonna leave it as average right now because that's what we have to do. We're not gonna have to actually go through and find the mean for these examples. Again, that Greek symbol that we're gonna use is mu, right? So make sure you know that the mean, we're always gonna represent it with mu. So as I go through and I label our normal curve that you see over here to the right, I'm gonna be using that sign mu. Okay, here, let me put mu. For our standard deviation, again, that's what we spent that last week going over. The standard deviation is, we're just going to put average distance away from the mean, right? Again, it kind of tells us how spread out our data is. The big thing that we're going to be using, again, is that Greek symbol. That's sigma. Again, it looks kind of like a cursive O, I would say, but that's sigma. From that, we can use the mean and the standard deviation to set up a normal curve. Now, when we go through and we do a normal curve, this is kind of a general way to look at information that's given to us. We can look at different sets of populations, and we can use this idea of the normal curve. We can use the normal curve when they tell you it's a normal distribution. As we go throughout this, we'll always be looking at the distribution. But what we know is that if we have something and it's in a normal distribution, we can use this normal curve over here to the right. It allows us to tell us approximately what percentage of data lies away from the mean. So I'm just going to say shows us approximate percentage of data. I'm going to put in relationship to the mean. And how we're going to look at it is we're going to look at it through standard deviations. So how it works is there's a rule. It's called the empirical rule, and what we know is we have these three percentages: 68%, 95%, and 99.7%. What we know is 68% of the data will lie within one standard deviation of the mean. 95% will lie within two standard deviations. 99.7 is within three standard deviations. Now we're going to use these percentages to fill in the normal curve, and I'm going to give you guys some different percentages to look at. But how we're going to use this normal curve here is this middle line, right? This is our normal curve. This middle line, that's your mean, right? I'm going to put mean. So they're going to give us an average. They're going to give us a mean. That goes right there in the middle. Now, again, the standard deviation is saying how far on average away we are from the mean. So each jump to the left or to the right, we're just going to be adding one standard deviation or subtracting one standard deviation. So if we go over to the right, 1, we're going to say we're going to add 1 standard deviation. Right? If we go to the right, 1 more on these lines, right? Now we're adding 2 standard deviations. right, from the mean. One standard deviation is the jump each time. So then we go another jump to get to this third line. We're at adding 3 standard deviations, and that gets us to the end, which instead, if we're going to the left, let me try to make this a little bit easier. We are instead subtracting 1 standard deviation each jump. So that's all you need to know is each jump we're either subtracting or adding a standard deviation. Now how that helps us is because if we use that empirical rule that I just talked about up here in the right hand corner, what we know is within 1 standard deviation there's 60% of our data. So within 1 standard deviation means 1 to the right of the mean and 1 to the left. So we're looking at this piece of our, that piece of our curve right there. That would be within 1 standard deviation, and what we know is 68% of our data lies right there. Now what we can do is we know that if 68% of our data lies there, we can cut that in half and that will give us our individual percentages. So we can say that 34% lies to the right, 1 standard deviation to the right, 34% lies 1 standard deviation to the left. Now again, what we're going to do is we're going to find all of these percentages so we can make our lives a lot easier as we go through and do these problems. Now, we go out one more step, right? Now we're jumping out to this level, which is 2 standard deviations. Again, from this empirical rule, we know if it's a normal distribution, 95% of our data should lie within 2 standard deviations. So the challenge is we want to figure out what are these percentages that we're going to put here. The easiest way to do it, we already know that 68% of our data is within this first jump. So to find the second jump, we're just going to go 95 minus 68. Again, make sure you have a calculator ready so you can go through and do this. 95 minus 68 is 27. Divide that by 2 because we're cutting that up into 2 different equal pieces right there. And that's 13.5. So what we know is this segment right here has to be 13.5%. Because we already knew 68%, we know that if we went one more jump out, it's 95. We subtracted them, that gives us those interior pieces. We're going to do this again. Again, what we know is within 3 standard deviations now, so now we're jumping out to this farthest point. We know that within 3 standard deviations, 99.7% of our data lies there. So again, what we want to do is find what that percentage is, so then we don't have to go through and do all this work. So very similar, we're just going to go 99.7 minus 95. Again, make sure you have your calculator ready. 99.7 minus 95 is 4.7. Again, we're going to take that and we're going to divide it by 2. 4.7 divided by 2 is 2.35. So what we know is in these smaller pieces here, 2.35% of our data has to lie here. The last thing that we want to do is we want to fill in this entire piece. We want to know every single piece. So we need to do those last 2 pieces there, the very end tails of our graph. And the way we're going to do that is what we know is this entire curve, right? This entire curve here has to represent 100% of our data. All we have up till now is 99.7% of our data. So very similar to how we just did those last 2 pieces, we're going to go 100 minus 99.7. Again, if you need to use a calculator, use a calculator. That gets you 0.3. And then with that 0.3, again, we're splitting it up between these 2 pieces. So we go 0.3 divided by 2, and that gives us 0.15. So this has to be 0.15% of our data. So what we've done is what we know using the empirical rule within one standard deviation, 68% of our data, right? 68%. Within 2, we have 95%. Within 3, 99.7%. We were able to use that to figure out these percentages. Why that's beneficial is because notice how it's the exact same thing on both sides of the mean. So really all we need to do is remember 34%, 13.5%, 2.35%, 0.15%, and that's going to allow us to fill in this table every single time. The last thing I want to say here, to check, we can check a normal curve to make sure we have the percentages right by adding up all of those percentages, right? If I add up all those percentages that I just underlined, that's 1/2 of our curve. So it should add up to be 50%. So if we just punch into our calculator, 34 plus 13.5 plus 2.35 plus 0.15, that should give us 50. Let me do that real quick. We can check and then we can be on our way. 34, 13.5, 2.35, whoops, sorry, 0.15, and yes, that sure does give us an even 50, which is good. So you can always check yourself to make sure you're right. Now again, this first lesson was just to introduce you to this idea of the normal curve. I know it's a lot to kind of look at right now, but the main thing is I need you to be able to fill in these percentages when we have a normal curve, because in the next couple of lessons we're going to look at how we can use those to find some specific information on a set of data. If you have questions, again, feel free to let me know. Have a good day.